Okay, another area problem for us. They tell us observe the function f of x equals x, so y equals x. That means this line contains points like 1, 1, 2, 2, 3, 3, 4, 4, and so on. And they want us to find this shaded area here. This appears to be minus 1 in the x direction, which means this point, sorry, I'll use a contrasting color. That point right there should be minus 1, minus 1. Then that right there is x equals negative 2, so this corner should be negative 2, negative 2. So if we want that area, we could do it with no calculus because that shape is a trapezoid. And if you know that the area of a trapezoid is h over 2 b1 plus b2, we could use that. Let's see, the height of this thing is 1 unit, so 1 over 2. b1 is 1 unit, that's one side, and this side is 2 units, so we'd get 1 plus 2, which would be 3 over 2, or 1.5. So the area of that trapezoid is 1.5 units according to geometry. But now let's see if our new calculus tricks can do this for us. What they're asking for is the area under, in this case it's above, but we tend to call it, or the area bounded by the line f of x, the area under y equals x from minus 2 to minus 1. And the fundamental theorem of calculus that we just met tells us we can get that by doing the integral of x dx from minus 2 to minus 1. So that means we find the antiderivative of this. Increase the power by 1, divide by the new power. I'm not leaving off c's, or sorry, I'm not including c's as discussed before because they're not going to matter. They will cancel out. So this is our antiderivative, and we're going to evaluate it at minus 2, and we're going to evaluate it at minus 1. This line is a way of saying calculate this value at minus 1 and at minus 2 and subtract them. You'll see this a lot when we're doing integrals. Some people never use it. I don't mind it. It's kind of handy. It just means plug minus 1 into this, plug minus 2 into this, and subtract the two results. And this is just a simple vertical line. I didn't mean for it to look like anything more complex than that. So we do 1 half, I'll give big brackets around this, 1 half negative 1 all squared minus, and now I do negative 2, 1 half negative 2 all squared. And that gives us, negative 1 squared is 1 times 1 half, minus, that's this negative sign, negative 2 squared is 4 times 1 half is 2, and that gives us minus 3 over 2. What happened? When we did this by geometry, we got 1.5. Now we're getting negative 1.5. And this is just a quirk of the integral. When it sees a height like this, which is negative, all of this gets counted as negative area. So it looks at this as being an area which is negative 1 units high, and over here it's a unit that's negative 2 units high. When that happens, the integral will spit out a negative area value. You can see the number is right, but this is something that you have to anticipate. Anytime you've got a function that goes under the x-axis, negative area is going to come out of that. If you did an integral over here, where this is above the x-axis, it would consider all this to be positive area. So there will be some examples up ahead where we're going to have to anticipate this or we'll get incorrect answers, but here it just means this answer pops out, it's got a negative sign, we say silly integral, areas can't be negative, and we would discard this and say there's an area of 3 over 2 units below the x-axis.